Welcome to this tutorial on customer segmentation analysis. In this video, we will walk through a popular project in data science using machine learning to group customers based on their behavior. And for that, we'll be using k-means clustering, which is a method for finding patterns in data. Now, our first step would be importing the necessary libraries, which basically we'll be using in this particular project. So we start by importing the necessary libraries and think of the libraries as tools that give us extra functions without needing to write everything from scratch. As you can see, we have imported pandas, numpy. So pandas is basically used for handling the dataset and numpy is specifically for numerical operations. And matplotlib and seaborn for data visualization, for charts and etc. Then we have imported k-means from scikit-learn.cluster. Then there is a standard scaler. We'll discuss it at the end of this particular video. And this import warning is basically for hiding the unnecessary warnings to keep the output clean. Then our next step would be loading the dataset. Now we load the dataset which contains customer information like age, gender, income, spending score, etc. And we have used df.head, which is basically for showing the first 5 rows, so we get an idea of what exactly our data looks like. As you can see, we are here you can see from index 0 to 4, which is basically first 5 rows of the dataset. And then we have df.info, which gives us a summary of the dataset, the number of columns, like the average income or the typical spending score. See, you can see this is the output from the df.info, where we have basically you can see this index from 0 to 8, which means there are 9 columns present, and each column has around 1000 rows. And you can see that it shows non-null. It means that from 0 to 8 index there is no column that is having any null values. All right, and you can also see that we are we can know from this that if each column has integer type or object type, the data type basically of the columns. All right, then after that we are checking that is there any null value that are right now are present in our data set. So for this we are using df.isNull.sum, and from the output you can guess that right now we don't have any null values. Then after that we are dropping some unnecessary columns, and here we remove the id and the preferred category column because they are not important for clustering. So the id is just a unique identifier and preferred category is not needed for segmentation. And after dropping them, then we are using hot encoding for gender column. Why? As you can see here, yeah, so you can see that gender and preferred category, both these columns are having categorical values. So right now we have removed the preferred category, but we are having gender as categorical columns. And in machine learning you can't fit categorical columns in algorithms, so we are using one hot encoding. Now one hot encoding turns the gender column, which has labels like male, female and other, into separate columns. Computers basically understand numbers better, so instead of male we get columns like gender male, gender female, gender other, with ones and zeros representing these categories. As you can see here, gender female, gender male, gender other, and ones and zeros representing these categories. All right, then we again use df.head to see the first 5 rows. Then after applying the one hot encoding, we are checking again that right now if we have any null values, so we can deal with it. So as you can see here, right now we don't have any null values. And after that, our sixth step is scaling the data. Now scaling is used to make sure all the columns have similar importance. For example, You can see that income is in thousands, while the membership years are in single digits. So without scaling, income would dominate the model's learning. You see, income in is it's in thousands, and the membership years these are in one digit, 329. So for that, we'll be basically using scaling, and for scaling, we have used one hot encoding, and we have imported the library from this standard scaler. So we use a standard scaler which adjusts all values, so they have a mean of 0 and a standard deviation of 1, making them easier for the algorithm to handle. And let me show you the output of it. Here you can see that the numbers have changed. All right. So after that, our seventh step is finding the finding the optimal number of clusters with the help of Albow method. So now let me explain what is WCSS. As you can see here, WCSS, and what is exactly the Albow method. So WCSS stands for within cluster sum of squares, which measures how spread out the points in each clusters are. The smaller the WCSS, the more tightly packed the points in a clusters are. So right now we are trying the numbers of clusters from 1 to 10 and 1 to 11 and plot them. The Albow method looks for a point where adding more clusters does not improve the WCSS much, and this point looks like an elbow in the graph. So after running it here, the graph looks like this. So you can see that this line exactly looks like an elbow. So based on the Albow method, let's assume 4 clusters are the best fit. So we apply k-means clustering with 4 clusters. Here we are applying uh, the optimal number of clusters, assuming it's 4, and and the fit predict function assigns each customer to one of these clusters. Here you can see fit predict. It is a method, and after that we are basically running one more time df.head for seeing the first 5 rows, and after that we'll be plotting the results, so visualizing the clusters. And we have used matplotlib. As you know that we have imported matplotlib as plt. Here matplotlib.pyplot as plt. So you can see that we have used plt.figure, plt.plot. So basically we have used matplotlib to visualize the clusters, and each dot is a customer. You can see that each dot is a customer here, and they are basically grouped into clusters based on their income. Here you can see based on their income and spending score. And the yellow dots represent the centroids, which are the center points of each cluster. Then after that, the last step is finally we analyze each cluster. Now this helps us understand the characteristics of customers in each group. For example, say one cluster might represent high income, high spending customers, while another might be low income but frequent shoppers. Alright, so for that we have used the df.groupby function. So if we come to a conclusion, so in this project we learned how to group customers based on their behavior using k-means clustering, and this is a valuable technique used by businesses to target marketing, optimize services, and improve customer satisfaction. So that's all from this tutorial. Don't forget to subscribe for more tutorials like this. I hope you guys like this video.